Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my videos and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In the last video, we have discussed how to divide a class C network into three subnets such a way that subnet 1 will consist of 128 IP addresses, subnet 2 consists of 64 IP addresses, and subnet 3 consists of 64 IP addresses. Even we have computed what is the subnet ID and direct broadcast address of each subnet. In this video, we want to discuss how to compute the subnet mask. Is it clear? Already we have discussed the subnet mask for an equal partition, meaning is that all the subnet consists of equal number of IP addresses. But however, in this one we have different IP addresses. Is it clear? S1 and S2 is having different, however S2 and S3 are having same. Is it clear? So this concept we will call it as variable length subnetting, and computing the subnet mask for it is variable length subnet mask. This kind of division we will call it as variable length subnetting. Okay, and computing the subnet mask for these kind of things is called variable length subnet mask. So let me compute the variable length subnet mask. Why we are saying variable length subnet mask, you will understand. As you already know that how to compute the subnet mask. Those who have watched my earlier videos, they can easily tell how to compute the subnet mask. You have to keep the ones in the network ID and the subnet ID parts. Am I right or wrong? Means if you take any IP address, we will have the network ID and host ID. And if you want to perform the subnetting, you would have borrowed some bits from the host ID to make it as a subnet. So in this example, if you see that I have taken 2 bits to borrow from the host ID and made this as subnet. So these bits will call it as a subnet bit. So in the subnet bits and in the host network ID bits, you keep ones, and in the host ID part, you keep the zeros. Then you can easily compute the subnet mask. Let me take this one. Okay. Subnet mask for S1. How can I compute it? As it is a class C network, 24 bits are allocated for the network ID. Will you accept it or not? 24 bits are allocated for the network ID and remaining 8 bits are allocated for the host ID. Out of 32 bits, 24 bits are allocated for network ID, 8 bits are allocated for the host ID. And to make this subnet, like subnet 1 and subnet 2, first what we have done, if you have watched my previous video, this 128 and 128 I have divided. Am I right? To divide into 2 subnets, I have borrowed 1 bit. So 1 bit where from I have borrowed? From the host ID part I have borrowed. So 1 bit is borrowed for the subnet and the remaining 7 bits are for the host ID. So totally 24 bits are there for the network ID and 1 bit is for the subnet and remaining 7 bits are there for the host ID. So if you keep ones in the network ID and the subnet ID, what you will get? 24 ones you should keep first. So if I keep 8 ones and convert into decimal number, I will get 255. And remaining 8 bits, if I keep it once, then I will get 255.255.255. Why I am converting into decimal? The IP address should be represented in a dotted decimal representation. So you will have a decimals and separated with a dot. Okay, how many decimals will be there? 4 decimals because it is a 32-bit number. So 8 bits you will convert into a decimal, 8 bits you will convert into a decimal, 8 bits you will convert into a decimal. Now if you see that first bit is taken for the subnet ID and the remaining 7 bits are the host ID. 3, 6, 7. 7 bits are for the host ID. Why I am taking the first bit? We have discussed that to have the IP addresses in sequence, you have to borrow that bit from the MSB of the host ID. Okay. So here if I keep 1 and remaining all are zeros, then we can compute the subnet mask. So if you convert this binary number to decimal number, you will get 128. So subnet mask for this one will be 255.255.255.128. Now you can ask me, sir, if it is a equal size subnet, then we have only one subnet mask. In one of the earlier video, we computed the subnet mask, and for these two subnets, it will be same. Am I right? But however, in this case, okay, let me write here. We got one subnet mask is 255.255.255.128. Now if you see that, can I erase this one? If you see this one, again this 128, we further divided into 64 and 64. So this initially this one was 0 and this one was 1, because one bit we have borrowed and to make it into two subnets. And then again this subnet I want to further divide. So again I have taken another bit, assigned 0 here, assigned 1. This is the way we have done the subnetting. Now again we need to compute the subnet mask here, because this one is having only one subnet ID and these two are having two subnet IDs. Obviously, here you have to keep 1 and here you have to keep both the values as 1 while you are computing the subnet mask. Am I right? So let me compute the subnet mask for these two. So already 24 bits are there for the network ID. Out of 8 bits of host ID, 2 bits you have borrowed for the subnet, and remaining 6 bits will be there for the host ID. So now how you will compute the subnet mask? These two places you keep 1s and in the host ID part you keep 0s, then you will get the subnet mask. Okay, now tell me, if I keep 24 1s, what I will get? 255.255.255. And 2 bits you have to keep 1s, they are MSB bits, and then remaining 6 bits you have to keep zeros, because the remaining 6 bits are the host ID. So what is the value you will get? 192. If you convert into decimal number, you will get 192. How? 128 plus 64 is 192. So you are getting two subnet masks. One is that 255.255.128 and another subnet mask is 255.255.255.192. Now you can ask me which one you will take. You will take both. How it will be, we will discuss now. Coming to the routing table, let's take that I have a router here, and or let me erase this diagram and draw it properly so that you will understand. So one large network, okay, we have made it into small networks 3, S1, S2, S3. Okay, this is my router. Now each one will be connected with an interface I1, I2, I3. Am I right or wrong? So if you have a router like this, for this router you should have a routing table. So what is the information will be there in the routing table? Network ID or subnet ID, because you are saying that we are making into subnets, meaning is that we are making into small networks. So you can call it as a network ID also. And you will have the subnet mask and you will have the interface. Are you able to follow it or not? You will have the network ID, you will have the subnet mask, and also you will have the interface. What is the network ID for this one? As you already know that the first IP address in the subnet will act as a subnet ID or network ID. Why? How we will get the network ID or subnet ID? In the host ID bits, if you keep all zeros, then you will get the network ID or subnet ID. Am I right? So, which is 193.1.2. Okay, 0 and 193.1.2.128, 193.1.2.192. This is for S1, this is for S21, this is for S31. yes, not S31, S22, because we have made it into 3 subnets. So the subnet IDs of or the network IDs of each one. Now can you tell me what is the subnet mask for this one, which will be 255.255.255.128. I hope you are able to understand. What is the subnet mask for these two? Will be 255.255.255.192. Is it clear? And even for this network also, let me write here 193.1.2.192. even for this one also you will have the same subnet mask. So the routing table will looks like this. Okay, 193.1.2. and its subnet mask, 193.191.2.128 and its subnet mask, and this subnet mask. Okay, now can you tell me to which interface they are connected? This one is connected with interface 1, interface 2, interface 3. Now how it will identify to which interface it has to send? This is the routing table, it will be there. Am I right or wrong? You will also agree. Okay, let me erase the remaining part so that I can use this space. Let's take the destination IP address came as 193.1.2. some 129. Let's take that. Okay, this is the address I got, destination IP address. I got the router got this packet. Now what the router will do? First it will take this subnet mask 255.255. Okay, 255. Okay, 128 it will take. Am I right? This is the subnet mask 255.255.255.128, and it will perform the bitwise AND between the subnet mask and the destination IP address. Okay, we will perform the bitwise AND. Can you tell me what is the bitwise AND? If you have both the inputs as 1, the output will be 1. If any one of the input is 0, you will get the output as 0. Am I right or wrong? This is the principle of bitwise AND. Now, if you see, take this one 255. 255 is nothing but all ones in the 8 bits. Am I right? 193, if I convert into binary number of 8 bits, then it will be 11000001. You can ask me, sir, how you have written like this? Have you by-hearted it or not? No. Why? This is 128 plus 64, which is 192 plus 1, 193. Is it clear? So, if you perform bitwise AND, what you will get? 1, 1, 0, 0, 0, 0, 0, 1. Am I right or wrong? So this is the number you will get. Can you convert into decimal number? And tell me what is the number you will get? You will get 193. Because sir, just now you have written 193 as like this. So it is what I got. So this is 193. So if you perform bitwise AND, you will get 193. What I want to say is that, okay, with 255, if you perform bitwise AND with anything, the same number you will get. Similarly, here you will get 1. If you want to verify, you can verify, and you will get 2 here. And then 129 and 128. If you perform bitwise AND, what you will get? Okay, 1 0 0 0 0. Okay, 5 6 7 8. This is the 129. And you will have 128. Okay, if I perform the bitwise AND, what I will get? 1 0 0 0 0 0 0. Am I right? Now what is the decimal number of this binary number? Which is 128. So what is this number? This is the subnet ID of this one. So you got 193.1.2.128 you got. Now what is the network ID of this one? This is 193.1.2.0. which is not matching with this one. Are you able to follow it or not? Because you have taken the subnet mask and the destination IP address, you got some subnet ID, means you got the network ID. Okay, now you will verify whether this network ID and this network ID is same or not. If it is same, the router will transfer the packet using the interface I1. Are you able to understand it or not? However, these two are not same, so it will not transfer the packet using the interface 1. Then what it will do? It will take this subnet mask. Okay, let me erase. What is this subnet mask? 192. Okay, this is 192. So it is taken this subnet mask because it is not matching with this one. Next is this one, 255.255.255.192, and the destination IP address in the packet. Again it will perform the bitwise AND. What is the value you will get? Can you tell me? If I perform bitwise AND between 193 and 255, obviously you will get 193. 1 and 255, you will get 1. 2 and 255, you will get 2. Just now we have solved it also. Now let me solve how to convert the bitwise AND between 129 and 192. So first 129, I need to convert into binary number. What I will get? 1, 5, 6, 7, 8. Okay, 1008 bits will be there. 158. Yeah, this is 129. How I got? 2 power 7 is 128 plus 1 is 129. And 192, how I will write? 110000. Okay. Now, if I perform the bitwise AND, what is the number I will get? See, 192, I have converted into binary number and I got 1160. Okay. Now you perform the bitwise AND. What you will get? 1, 0, 0, 0, 0, 0. Everything you will get 0. So, you got 1 7 zeros. Convert into decimal number. What you will get? You will get 128. Keep the 128 here. So, if you perform the bitwise AND between the destination IP address and the subnet mask, you got the subnet ID as or network ID as 193.1.2.128. So, it is matching with this one. Am I right or wrong? Is it clear? So, you have taken the destination IP address and subnet mask of this one. It is matching. So, then what is meaning? The router will transfer this packet using the interface 2. Interface 2, which one is connected? Subnet S21. So, this packet will be transferred to this subnet, because obviously if you also verify in this subnet 128 to 191 IP addresses are there. Am I right? This is the range. So, 129 will belongs to what? 129 IP address will be there here only. So, even if you check as a human eye, you can say how the router will do. Router will do like this. So, I hope you have understood how to compute the subnet mask for the variable length. Okay, and then what the routing table will consist of. Okay, and how the routing table will check to which interface it has to send. I hope you have understood what are the concepts discussed in this video. If you still have any doubts, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. If you really like my video and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. Thank you for watching my video. Have a nice day.